Hey guys, so I have the learning target already written down. You can pause the video and write that. But I'm going to go ahead and move on. We were talking about volume of pyramids and cones today. So we've got a couple new formulas, but the nice thing about these formulas is like all the components of them you've already used in the past. So like if you look here, this volume equals BH divided by 3. We've already used V equals BH as a formula, and all we're doing is dividing it by 3. So you already know what these things are, which is nice. The B, capital B, still stands for area of the base. So I'm going to grab my highlighters and then go ahead and highlight the base, which let's do pink for that. And one thing that you may notice about this is that there is only one base, which is nice. Like unlike prisms where you had to choose 2 of the bases. And then your height, I want you to notice this is a different height than the one for surface area. This one is H, it's not that cursive L. That cursive L was slant height, where it was like along the side right here. But this height is just the normal height. So if you think of how tall something is, how tall is this pyramid? Yeah, that's this height that we're talking about. So, the word height, it actually is how tall this pyramid is. Okay. So we've got the area of this base. And remember, the capital B always changes based on the shape of your base. And this particular one is a square. So it's just simply B times H. So 3 times 3. You just multiply them together. You don't have to divide or anything because that pink shape down there is a square. 3 times 3 is 9. I've got my capital B. Awesome. Now my height, I've highlighted it in green. I'll go ahead and highlight the B and H as well, so that those don't get mixed up. 5 is going to be our height, which is right there. And then our formula is just 9 times 5 divided by 3. So I'm going to click Control Divide in my calculator, do 9 times 5 in the numerator, and in the denominator put a 3, and I'm going to get 15 for my answer. And it's 15 units cubed because this is volume, so it's how many cubic units will fill up if we're trying to fill that with water or something. It would take 15 cubic units to do that. All right, let's move on. Use the same formula. Ooh, this one is a little different though, because if you notice, our base is not a square. So I'm going to take my highlighter, get my pink one again, and I'm going to highlight, this one is a right triangle. And then the height is right there at 6. So I can go ahead and put the height in as 6. And my base, so remember, for triangles, it's base times height divided by 2. Zoom that in a little bit, make it easier to see. And then I need to find my right angle. We struggled with this on Unit 12, finding the 2 sides of the triangle that need to be multiplied as the base and the height. So just make sure you realize that it's the 2 sides that touch the right angle. So 3 times 4 divided by 2 would be your capital B, which I probably should have just written this out here. 3 times 4 divided by 2, so that's going to be 6. So 6 is going to be your height, and 6 will also just happens to be the area of your base. And then our volume would be capital B times H divided by 3. So I can plug those in. 6 times 6 divided by 3. Grab my calculator. Six times 6 divided by 3 is 12. That's what our volume is going to be. All right, and then we are going to move on to this next example. And if you notice, so I'm going to, we have a pyramid here, and the base is a rectangle. We have a rectangular pyramid. We do not have this height. So this H is what we're looking for. But something we do have is this little triangle drawn in here, and it has an angle 60 degrees. We don't have this, the slant height or the hypotenuse for that little mini triangle, but we can figure out what this line is right here. And the way we can do that is by just taking this 10 and cutting it in half. If you divide it in half, you get the length of that side, which is 5. And so now you have this triangle over here. I'm actually going to call this X, 5 and 60. And we can use trig to find this. So 60 is my reference angle. And I want to label my two sides. Remember, right angle's here. So we don't have, nor are we looking for the hypotenuse. So I'm not going to label that. X is opposite of this angle because it's way on the other side of the triangle. It does not touch our angle, so it has to be O. Adjacent does touch the angle. This 5 touches that angle, so it has to be the adjacent side. So if you guys remember, I'm going to write this on here. I would write this on your notes as well. We have this SOHCAHTOA here. And we only want the one with O and A, which is going to be tangent. So tangent of our angle, if you guys remember how to set that up, is equal to our opposite side over our adjacent side. So X over 5. And then X is on top, so we are going to multiply 5 times tangent of 60. And that's what we're going to put in our calculator, so let's go ahead and do that. Oh goodness, I'm struggling with my calculator here. 5 times tangent of 60. And we are going to get 8.7. We'll go ahead and round this to the nearest tenth. X is 8.7. That gives us our height. Right? So since that gives us our height, we can find our capital B, which will be just base times height of the pink shape, because that pink shape is a rectangle. So 8 times 10 will be 80. Let's make sure everything's fitting in there. Great. So I have my H, I have my B, I have everything I need to plug it into my volume formula. So BH divided by 3. My B is 80. My H is 8.7. Am I running out of room on the screen? I am. Divide that by 3. So let's put that in the calculator. 80 times 8.7 divided by 3. 232 exactly. And that will be our volume. This is our last example for pyramids. We have this crazy looking shape on the bottom now, don't we? I'm going to go ahead and highlight it, if you'll do the same on your paper. And then, okay, this is kind of confusing here. So this 2 right here is actually the distance from the center to the edge of this pink shape. The 7 is going to be the height, so I'm going to highlight that in green and go ahead and write that in as my h. But my capital B is what's a little bit different here, because if you look at this shape, you're like, ooh, it's got 5 sides. That's weird. It is, it's not a square, it's not a rectangle, it's not a triangle, but if you look in the front of your packet, which I will turn to it, here's my formula chart. We look and we're like, yes, it's this one. It's a regular polygon. So it's that AP divided by 2 formula that we learned a couple units ago. So I will write that in here, AP over 2. So this is a regular polygon. All of these sides are the same, even though it doesn't really look like that. We're just going to assume it is. The A stands for apothem, which is the distance from the center to one of the side lengths. So 2 is going to be your A. Your perimeter, there's 5 sides, each of them equal 3. So 5 times 3 is 15. And then we will divide that whole thing by 2 because, well, that's the formula, AP divided by 2. So what happens here is those cancel out. And 15... Oh, goodness. That was on the screen. It didn't really block anything, though. Yes. So your capital B is going to be 15. All right. And then our last step is just volume equals BH divided by 3, which equals 15 times 7 divided by 3. So control divide. 15 times 7 divided by 3, and we'll get 35. All right, and that's pyramids. Let's move on. On to cones. So it's pretty much the same thing, the same idea. It's the area of the base, which is pi r squared because it's a circle, times the height divided by 3. So, I mean, I said there were 2 different formulas today, but it's kind of the same formula, just, in a different form. And you know what? I'm going to start by highlighting this circle. Highlighted. Awesome. And then I'm going to highlight my height. I'm just going to connect the top of the cone to the center of the circle. And then I just need R equals and H equals. My radius is 3, my height is 5. Let's plug some numbers in and be done. So the volume equals pi times 3 squared, the radius squared, times my height, which is 5, all divided by 3. So the first time I put it in the calculator, I am going to put it in without pi, all right? So we have 3 squared times 5 up in the numerator, and then in the denominator we have divided by 3. And then we end up with 15. And then don't forget your pi, because if it wants it in terms of pi, we're going to answer all of these in 2 ways. In terms of pi, so 15 pi would be the answer, and then it would just be units cubed, because this is volume. And then I'll take my 15 and I will multiply it by 5, or by pi, and I will get 47.1 units cubed. And then those are my 2 answers. Another way you can do it is grab that up there, just multiply this by pi, you'll get the same answer. That's just another way if you'd like to do it that way. All right, let's go on to the next one. I have my height. Ooh, do I have my height? Is it 15? Ooh, it's not, right? So what do we have going on here? We have something that we're looking for. I'm going to put an X there. And then we know that the diameter is 18, but this makes a triangle right here. So can we figure out what that radius is? Which we can. Our radius is going to be 18 divided by 2, or 9. And now we've got this triangle here, and I'm going to redraw it over here. So we have 9, we have 15, and we have x. We are going to need to use Pythagorean Theorem to solve for this. So our hypotenuse is 15, so that has to go where the c goes. And then 9 squared, and we are looking for this side right here. All right, 9 times 9 is 81. 15 squared is 225. And then we're not adding these two numbers together. We are going to subtract because we want a squared all by itself. 225 minus 81, and we get 144. Then our final step would just be to take the square root of both sides, and our a would be 12. So this side of that triangle is 12 units long, so that's going to be the height, and we had to use Pythagorean Theorem to solve for that. But now we have everything we need. We have our h, and we have our radius. So the volume is going to equal pi r squared h divided by 3. So let's plug those things in. Pi times 9 squared times our height of 12. And divide the whole thing by 3. So I'm going to put it in my calculator without pi first. 9 squared times 12 divided by 3 is 324 pi. Or 324 times pi is 1,117.9. And those are our answers. All right, this problem right here, there's a few different ways you can look at it. We need to figure out what the radius is, because we don't have anything marked there. We already have the height. Our height is 6. And then if you notice here, this is a 45, 45, 90 triangle. And when we talked about these, we talked about how the legs were going to be the same as each other, right? Because if this is 45, this leg across from this angle and this angle, if the angles are congruent, the sides must also be congruent. So the diameter is 6. But if you use the 6 as the radius, you'll get it wrong. This side length is 6, this side length is 6, but our radius by itself is just 3. And then we have everything we need to plug in to our formula of pi r squared h divided by 3. So pi times 3. Let me white that out, make it prettier. Pi times 3 squared times 6 divided by 3. And we'll control divide. 3 squared times 6 divided by 3 equals 18 pi. All right, 18 pi. And then two ways you can do it. You either multiply 18 times pi or go back and put pi in the denominator. But you'll end up with 56.5. Alrighty, so this is the last example, and I don't want you to look at this and cringe because this is not surface area. So don't freak out. You look at this, and I know that you can see we've got cylinder and cone, but there's not the craziness of surface area figuring out what's showing and what's not. It's just simply take the cylinder volume and add it to the volume of the cone, and that's it. No extra craziness. So I'm going to find my formula chart in the front, and I want to write this formula down. Volume equals area of the base times height. But for a cylinder, it could also be V equals pi r squared h, because the circle base will always be pi r squared, and the h stays the h. So I'm going to write pi r squared h. And then for the cone, I have the slant height, but I don't need the slant height. I need the actual height, so just make sure you pay attention to this. The diameter of the cylinder up here is 6, so that means the diameter of this cylinder is also, or this circle is also 6. So 3 is going to be that radius. And I'm going to have to use Pythagorean Theorem to solve. So 5 squared, 3 squared, so 9 plus b squared equals 25. So b squared is going to equal 25 minus 9, which is 16. And that means this is going to be 4. So b is 4. Your height, let me take the square root of that. Your height is going to be 4. So just make sure you pay attention to that. Your cone height is not going to be 5. You'd get it wrong. Okay. And then my cone volume formula is pi r squared h divided by 3. So literally the same thing, but divided by 3. Our radius and our height for our cylinder is 3 and 50. Our radius and our height for our cone is 3 and 4. Alright, let's do this thing. Let's plug this in. 3 squared times my height, which is 50, plus pi times 3 squared times 4 divided by 3. And we're going to put everything in the calculator except pi to start with. So 3 squared times 50 is going to be 450 pi. Then down here, 3 squared times 4 divided by 3, which is 12. And then you get 462 pi meters cubed. And then that's both of those added together. So it's substantially smaller for the cone volume than the cylinder volume. All right, thanks for watching.